All right, this is the answer key for the first part of the Chapter 8 practice test. This is in your booklet, go all the way back to the back section of Chapter 8, and I believe it is page 36 and 37. We're just going to be doing part of it, the part that we're focusing on in the chapter now, and it's looking to be able to tell whether we have a special right triangle, whether we're using the Pythagorean theorem or whether we are using the geometric mean to find the missing side. And then what we're making sure we're doing is simplifying our radicals, not leaving any decimal answers. All right, so as we go through here, the first thing that we look at is that we have a right triangle. We are given two of those three sides, so this is a Pythagorean theorem problem. So the first goal is just to identify that you know which type of problem that it is out of those types up at the top up there. And you can see that we don't know a leg, we have one leg, and we have the hypotenuse. And so if we use our Pythagorean theorem and then solve for x, we're going to see that x is going to be equal to the square root of 46. In number 2, you could see that we have a 30, 60, 90. That we are given the long side and we are looking for the hypotenuse. So I'm going to find the short side by taking the long side divided by the square root of 3, and that'll give me 15 radical 3. And then I'm looking for the hypotenuse, which was the x in our problem. So I'm going to have to take 2 times the short side, and then that is going to give me 30 square root of 3 for the hypotenuse. For the next one, you could see that what we have here is a geometric mean, and it is a one that uses a leg. So 6, there's our leg, so putting that in for our geometric mean, and then x, and then the whole thing would be x plus 5. This is one that when we cross multiply here, that we end up with a square. So we have to set this equal to 0 and then factor it. Since it's a quadratic equation, we are producing 2 answers, but the only answer that is credible to us is the answer x equals 4. So that will tell us what our x value is there. That was one of the missing parts. And then we're looking for y. If we look at y, then if we know that x is 4 and that this was x plus 5, then this is going to be 9 now. So we now know that this is 5 and that this is 9, and so we can use this side as a leg geometric mean. So the y goes there, the 5 and the 9, and we end up taking the square root of 45, which is going to be 3 radical 5. All right, if we look at numbers 4 and 5 next. Number 4, we can see is a 45, 45, 90. We are given the hypotenuse. So there, to figure out the leg, we take the hypotenuse and divide by the square root of 2, which then is 29 divided by the square root of 2. We end up having to rationalize that denominator, and we end up with an answer of 29 times the square root of 2 divided by 2. For number 5, you could see that what we have is a 30, 60, 90. And I've labeled the sides, our hypotenuse, our short side, and our long side. And so I'm going to start by finding the short side, which is the hypotenuse divided by the square root of 2. The hypotenuse divided by 2, which gives us 5 times the square root of 3. Now that is the short side, and we were looking for the long side, so the long side is the short side times the square root of 3. And so when I do that multiplication, I end up with the long side, which is our x in this problem, is equal to 15. All right, so moving up to number 6. Number 6, we are given a square, and so if we know that these angles are 90, we know that this is 45 and 45. So we have a 45, 45, 90. We are given the hypotenuse and asking for the leg. And so the leg is equal to the hypotenuse divided by the square root of 2. We do have to rationalize that. And then remember that we can divide that 6 and 2. And so that is going to give us an answer that x is equal to 3 radical 2, 3 times the square root of 2. In number 7, we can take and use the altitude as the geometric mean. So here is our geometric mean, and then if this is 9, then this must be 6 if this is 3. And so we're going to be able to take and cross multiply and divide there, and we end up with 18, and that's 9 times 2, so that's going to give us 3 times the square root of 2, and that'll be for this in here. And then we can take and use the leg over here, and then this is our geometric mean, 6 to 9 here, to set up this proportion, which gives us that we end up with y squared equals 54, which is 9 times 6, so we're able to take that 3 times the square root of 6, and that ends up being our y value, which is right here. For number 7, we're looking at, once again, that we have a x here and x plus 7 and a leg. So we're setting up a geometric mean. When we cross multiply, we end up with a quadratic with a square, which we then have to set equal to 0. And then we're factoring that. And when we factor that, remember that we're looking for the positive result. So our x there is 9. We are then going to use that if we know that x is 9. That we need to find this y value. And we can use a geometric mean there now with the altitude. And so this is going to be our, there's our y, and then 9 and 7. And so we're going to be able to cross multiply and get 63, and 63 is a perfect square of 9, and so y is going to be 3 times the square root of 7. All right, looking at numbers 9 and 10. Number 9 is we are given right triangle, and we're given 2 of the sides, so we can just use the Pythagorean theorem. The legs are given, we're looking for the hypotenuse. In number 10, we are looking at a 30, 60, 90 triangle inside of this equilateral triangle here. And so we could see that this is our, we are given our hypotenuse, and we're actually looking for the long side. So I'm going to find the short side first, say that it's the hypotenuse divided by 2, so that gives me 9 over 2. 9 divided by 2 is the short side. The long side then is then the square root, or the square root of 3 times the short side, and so we end up with 9 times the square root of 3 divided by 2. All right, if we take a look at number 11, number 11 is a 30, 60, 90. We were looking for the hypotenuse. I found the short side first by taking that long side, which was 2 times the square root of 15, and dividing by 3, and getting 2 times the square root of 5. To then find the hypotenuse, I would take 2 times the square root of 5 and multiply it by 2, which gives me 4 times the square root of 5 for the hypotenuse, which was our x value. For number 12, we have if this is 16 and this is 4, this must be 12. And so we're looking at this x, which is the altitude. So we could do a geometric mean with an altitude. There's our x's. Cross multiply and square root, we're able to take out a 16 there. And so we are going to make that 4 times the square root of 3. All right, number 13. We are given, it's a right triangle. We're given the hypotenuse and we're given one of the legs, so we're using Pythagorean theorem to figure out that the leg that is missing is 20. Number 14, if we look at this, this is a leg, and we then know that this is 4 and this is x plus 8. And so we can use that as a geometric mean. Notice that when we cross multiply, we get a square, a quadratic, so we have to set equal to 0, and then we have to factor, and then keep in mind that we are only looking for that positive answer. So our answer there would be x is equal to 8. That would make this 8. That would make this 16. Okay. In our last set of problems here, we had to determine if there is a triangle, and then what type of triangle the sets represent. So if we look kind of out of order here, but if we look at number 16 is not a triangle because when we take the two smaller sides, they equal the larger side. So we know that that is not a triangle. So in the remaining 3 problems, you'll see that in green, I circled the longer side, and we look at the square of it and compare it to the sum of the squares of the other 2 sides. And if they are the same, this is indeed a triangle, and it is a right triangle. If the longer side is greater than the sum of the squares of the other 2 triangles, which we have in 17, then we have an obtuse triangle. And then what we have in number 18 is that we have the sum of the square of the other 2 sides being more than the square of the larger side, and so what we have is an acute triangle.